Hello everyone, welcome back to the channel. Today we are going to learn about simple partial fractions in detail. We will talk about some terminologies related to it, and then we will also see the various methods to determine the partial fractions, and we will solve some examples as well. Let's talk about some terminologies at first. Let's define rational function. So we have um, two polynomials fx and gx. If we get a function hx by dividing fx by gx, here gx cannot be 0, then hx is a rational function. So this is one terminology, rational function. The second would be proper rational function, and the other would be improper rational function. So in this expression, if degree of polynomial of fx is less than degree of gx, then hx equals to fx by gx is proper rational function. Otherwise, it is improper rational function. Otherwise means if degree of fx is greater than or equals to degree of gx. So this should be noted. And the partial fractions can be evaluated only for proper rational function. So if we are given improper rational function, we need to change them to proper one by any method. And lastly, let's talk about partial fractions. So we can obtain the partial fractions only of proper rational function whose denominator is a product of two or more algebraic factors. Okay, and in this scenario we can break this proper rational function to simpler fractions called partial fractions. Okay, above kind of proper rational function can be broken down as a sum of two or more simpler fractions called partial fractions. Okay, and these partial fractions each have their denominator as one of the factors of the denominator of the proper rational function. Suppose we have a proper rational function 1 by x minus 1 x minus 2. This can be broken down to 1 by x minus 2 minus 1 by x minus 1. These are the partial fractions here. What the above statement told us is these factors in the denominator of proper rational function comes in one of the partial fraction, right? They will repeat here in the partial fraction. Okay, now let's talk about method of determining the partial fractions. To determine the partial fractions, we need to observe and check the type of the algebraic factor present in the denominator of given proper rational function. So, what is the basis? The basis is type of algebraic factor in the denominator of given proper rational function. Okay, we need to remember this type of algebraic factor. The first one is non repeated linear factor. Suppose we have ax plus b in the denominator of given proper rational function, meaning one of its partial fraction must have the form a by ax plus b. That is, suppose we have p by ax plus b and another is cx plus d, then this can be expressed as for one non-repeated linear factor, we can write a simple partial fraction as a by ax plus b, and for the other non-repeated linear factor, the simple partial fraction would be capital B by cx plus d. This is the meaning. Okay. So, for example, if someone asks us to find the simple fraction of, suppose, 3x plus 1 by x minus 3 times x minus 5, we can simply see that here the factors are non-repeated. There is x minus 3 has only power 1, it is not repeated here. So one's fraction should have the denominator x minus 3, the other should have x minus 5. Okay, and simply there are some other coefficients we need to determine a and b. The second type is repeated linear factor. Suppose in the denominator ax plus b is repeated r times. Okay, in denominator corresponding to this factor, there are group of let's say there is a group of partial fractions given by a1 by ax plus b plus a2 by ax plus b whole square plus and so on up to ar by ax plus b power r. So what does it mean? Suppose we have a proper rational function given by 2x plus 3 by x plus 2 times x plus 4 square. This is a proper rational function, obviously, right? We have x plus 2. This is not repeated linear factor. X plus 2 is not repeated here, it's a linear factor. So partial fraction corresponding to it should be a by ax plus b. That means x plus 2a. This is related to this one. Now we have here x plus 4 square. It is repeated twice. So it should have the form like this. Here r equals to 2. So it can have the form b by x plus 4. Let's say b1 by x plus 4 plus b2 by x plus 4 whole square. Right? I hope you understood this one. And then you can proceed solving it. Let's see the next type. The other is non repeated quadratic factor of the form ax square plus bx plus c, right, which are not factorable. So instead of now linear factor, we have quadratic factor. but not repeated. So whenever this kind of thing comes there, the corresponding partial fraction is of the form ax plus b by ax square plus bx plus c. What does it mean? Example: suppose we have a proper rational function given as x square by x plus 2 and x square plus 3, then the partial fraction related to x plus 2 would be a by x plus 2, that's over. But for x square plus 3, we have the type this one. So it should be, suppose, bx plus c divided by x square plus 3. And then we can proceed solving it. And the fourth one, important for our exams, can be repeated quadratic factor, right? What does it mean? If ax square plus bx plus c power r is present in denominator, corresponding group of partial fractions is a1x plus b1 divided by ax square plus bx plus c plus a2x plus b2 by ax square plus bx plus c whole square plus arx plus br divided by ax square plus bx plus c power r. This is the form. That is example. We have proper rational function given as 4x square plus 2x plus 1 divided by x square plus 1 whole square. Then what we can do here is, since here is only repeated quadratic factor and up to 2 times, so there should be two partial fractions. One will have x square plus 1, the other will have x square plus 1 whole square. The first one will have the type a1x plus b1, and the second will have a2x plus b2. So up to this, we discussed the theoretical part of the topic, simple partial fractions. I hope it's clear up to here. Now we will solve the problem. We will do the examples related to each type of the algebraic factor and try to determine the partial fractions. Now let's look into some examples. Let's try to solve few questions. Let the question be resolved into partial fractions. Okay, this is our question. The first one, let's say, is 5x plus 7 divided by x plus 1 times x plus 2. So, how to do its solution properly? Let 5x plus 7 by x plus 1 times x plus 2 equals to. So, there are non-repeated linear algebraic factors. So, for x plus 1, we can assume the partial fraction to be a by x plus 1. Similarly, for x plus 2, we can assume the partial factor to be x plus 2. Let this be equation first. Actually, this is identity. That means for every value of x, this must satisfy. Okay. Or 5x plus 7 by x plus 1 times x plus 2 equals to a times x plus 2. Let's take the LCM here. B times x plus 1 divided by x plus 1 times x plus 2. Now we are left with, so this part gets cancelled out. We are left with 5x plus 7 equals to a times x plus 2 plus b times x plus 1. Actually, let this be equation first. Okay. Let this be equation first. Since this is identity, we can use any suitable value of x and try to solve this. My trick is, since there are two variables a and b, at first let's try to vanish any one of them. That means you can put x equals to minus 2 to vanish the first part, or x equals to minus 1 to vanish the second part. Let's say I want to use x equals to minus 2 so that this part vanishes out and we can get the value of b. We get 5 into minus 2 plus 7 equals to, this gets dismissed, this is 0, right? B minus 2 plus 1, or this is minus 10 plus 7, that is minus 3, equals to, this is minus b, that implies b equals to 3. Again, putting or using x equals to, now you can use x equals to minus 1, or since we have already known value of b, we can use x equals 0 also for simplicity. X equals to 0, we get 5 into 0, 0 plus 7, 7 equals to 2a, right, plus b, or 2a equals to 7 minus b, b is 3, or 2a equals to 4, that implies a equals to 2. Therefore, what we can write is 5x plus 7 by x plus 1 times x plus 2 is a is 2, b is 3, right? 2 by x plus 1 plus 3 by x plus 2. This is the answer. Let's try to solve another question. Let us suppose we are given to resolve 5x plus 4 divided by x square plus 3x minus 4. Now don't get confused here. Since there is only one expression, we cannot say these are in the form of product of factors, right? So we may have to factorize the denominator here. We have x square plus 3x minus 4 equals to x square plus 4x minus x minus 4 equals to x plus 4 minus 1 x plus 4 equals to x minus 1 times x plus 4. That means this is actually x minus 1 times x plus 4. Therefore, 5x plus 4 by x square plus 3x minus 4 is actually 5x plus 4 divided by x minus 1 into x plus 4. Now I hope you can do. This is this can be expressed as a by x minus 1 plus b by x plus 4. Let okay. Therefore, we get 5x plus 4 by x minus 1 times x plus 4 equals to a times x plus 4 plus b times x minus 1 divided by x minus 1 times x plus 4, or 5x plus 4 equals to a x plus 4 plus b x minus 1. Let this be equation first here. Now, just like previously, let's try to vanish any one of them. Let's use x equals to minus 4 at first. We get 5 into minus 4 plus 4 equals to a gets vanished and b will be minus 5, sorry, minus 4 minus 1, or this will be minus 16 equals to minus 5b. Therefore, b equals to 16 by 5, right? And again use x equals 0 now. Use x equals to 0. We get 4 equals to, from equation first, okay? We get from equation first 4 equals to 4a minus b, or 4a equals to 4 plus b, but we have b equals to 16 by 5, or 4a equals to 5 for 20, 20 plus 16, 36 by 5, or a equals to 4 divides 36 by 9, so 9 by 5. That is a equals to 9 by 5. Therefore, the after resolving, we got 5x. What is our question? 5x plus 4. 5x plus 4 divided by x square plus 3x minus 4 plus 3x minus 4 is written as 5x plus 4 by x plus 4 into x minus 1, right? Which can be further expressed as a by x minus 1. A is 9 by 5. So 9 by 5 times x minus 1. And then we have b by x plus 4. B is 16 by 5. So 16 by 5 times x plus 4. This is how we solve the problem. Okay, let's look into the third problem. 1 by x cube minus 1. Now, how to do this? Let's express the given function such that the denominator have products of the factors. X cube minus 1 can be written as, by using the formula a cube minus b cube, we can use a minus b into a square plus ab plus b square. This is the formula. Now you can see there are two factors. One is linear factor, the other is quadratic factor, and both are non-repeating. So the partial fraction corresponding to x minus 1 would be a by x minus 1, right? Then the partial fraction corresponding to the quadratic term is given by bx plus c by x square plus x plus 1. Yeah, I hope you remember all the discussions we did above. So therefore 1 by x minus 1 into x square plus x plus 1 equals to a by x minus 1 plus bx plus c by x square plus x plus 1. After taking the LCM and cancelling all the denominators, we are left with a times x square plus x plus 1 plus bx plus c into x minus 1. Now, how to solve this kind of problem? Always start vanishing this complex term. Use, let this be equation first, okay? Use x equals to 1 in equation first. We get 1 equals to a times 1 plus 1 plus 1, 3, right? And then bx plus c, let's not try to solve it. Here x minus 1 will banish this whole term, equals to 0. Therefore, a equals to 1 by 3. We got one value of the variable. Let's then use, now we have a, no problem with this term. Let's try to get c by using x equals to 0, because in this case b vanishes, right? Use x equals to 0 in equation first. We get, so 1 equals to a, this is 0, this is 0, remaining 1, a into 1. So b vanishes, only c left out, c times 0 minus 1 is minus 1, or a minus c equals to 1. We have a equals to 1 by 3. 1 by 3 minus c equals to 1, or minus c equals to 1 minus 1 by 3. This is equals to 2 by 3. That implies c equals to minus 2 by 3. Now we have a, we have c. Now you can find b by using any value of x. Okay, you can use anything else. For simplicity, let's use x equals to 2. Or you can also use x equals to minus 1 also. Whatever, you can use anything else. Putting, okay, let's go with minus 1. Minus 1 in equation first, we get 1 equals to a is 1 by 3, right? Minus 1 square 1, minus 1 plus 1 vanishes out. So a is left with 1 only. Similarly, plus b is minus b, right? And c is minus 2 by 3. And we have there minus 1 comma minus 1. That is minus 2. Or 1 equals to 1 by 3. And then minus, here also minus, here also minus. So plus 2b plus 4 by 3. 2b equals to 1 minus 4 by 3 plus 1 by 3, that is 5 by 3, equals to 3 minus 5 minus 2 by 3. Therefore, b equals to minus 1 by 3. Hence, what we can write is 1 by x minus 1 times x square plus x plus 1 is equal to, we have a by x minus 1 and a equals to 1 by 3. So 1 by 3 times x minus 1 plus, we have bx plus c. b is minus 1 by 3 x plus c. c is minus 2 by 3 divided by x square plus x plus 1. This is 1 by x cube minus 1 is equal to 1 by 3 times x minus 1. After doing some algebraic manipulation here, we can write minus x plus 2 by 3 times x square plus x plus 1. This is how we do the solution. Let the problem be 4x square plus 2x plus 1 divided by, we have x square plus 1 whole square. As this is already a proper rational function, because here highest degree is 2 and in denominator there would be highest degree 4. Solution. Now this is a quadratic factor repeated 2 times, right? So how we can assume, let 4x square plus 2x plus 1 divided by x square plus 1 whole square equals to, this is repeated 2 times, okay? So let's write the partial fractions like a1x plus b1 divided by x square plus 1 plus a2x plus b2 by x square plus 1 whole square, right? Or 4x square plus 2x plus 1 by x square plus 1 whole square equals to, let's take LCM here. LCM will be x square plus 1 whole square. We have a1x plus b1 into x square plus 1 and a2x plus b2, or they get cancelled out and we are left with 4x square plus 2x plus 1 equals to a1x plus b1 x square plus 1 plus a2x plus b2, or 4x square plus 2x plus 1 equals to, let's multiply this, we get a1 x square, sorry, x cube, right? a1 x cube plus a1 x plus b1 x square plus b1 plus a2x plus b2, right? Or 4x square plus 2x plus 1 equals to a1 x cube. Then we have terms related to x square is only b1 x square, and then a1 plus a2x, and then we have b1 plus b2. So comparing the coefficients, we get, also let this be equation second. Oh no, it's equation first. Comparing the coefficients, we get there is no x cube term on the next side, so a1 is 0. right? And then a1 plus a2 is 2. a1 plus a2 is 2. That implies a1 is 0, a2 equals to 2. Similarly, b1 x square, 4x square. So b1 is 4, right? And then we have b1 plus b2 equals to 1. b1 plus b2 equals to 1. That implies b2 equals to 1 minus b1 equals to 1 minus 4 equals to minus 3. Now we got the value of all the variables. Therefore, 4x square plus 2x plus 1 divided by x square plus 1 whole square can be written as, so a1x plus b1, we have their value a1 b1, right? a1 is 0, a1x plus b1 is 4 divided by x square plus 1 plus a2x plus b2, we have b2 is minus 3 by x square plus 1 whole square is equals to, we are left with 4 by x square plus 1 plus 2x minus 3 by x square plus 1 whole square. This is the solution. Now let's try to do some other few problems. We have x cubed by x plus 2 times x square plus 3. Is this proper? No, this is not proper rational function, right? This is improper because we have degree 3 here and then degree 3 in the denominator also. So what we have to do, we need to change this to proper rational function. At first, let's try to find the product of the factors in denominators. So x into x square, x cube, right? Then 3x, then we have 2x square, the last one is 6. Let's divide. Dividing x cube by x cube plus 3x plus 2x square plus 6, we get 1 times x cube plus 3x plus 2x square plus 6. This gets cancelled out. Minus 3x minus 2x square minus 6. Right? So now this is second degree term. Therefore, we can write x cube by x cube plus 2x square plus 3x plus 6 equals to 1 plus, this is the remainder, right? Minus 3x minus 2x square minus 6 divided by x cube plus 2x square plus 3x plus 6. This is 1 minus 2x square plus 3x plus 6 divided by x cube plus 2x square plus 3x plus 6 is x plus 2 into x square plus 3, right? X plus 2 into x square plus 3. Let this be equation first. Now we can get the simple partial fraction of this expression. So let 2x square plus 3x plus 6 by x plus 2 times x square plus 3 equals to x plus 2 is a linear factor. Corresponding partial fraction of x plus 2 will be a by x plus 2. X square plus 3 is quadratic factor, right? So simple partial fraction related to x square plus 3 can be supposed to be bx plus c by x square plus 3. Let's take LCM and simplify. We get 2x square plus 3x plus 6 equals to a times x square plus 3 plus bx plus c times x plus 2. So again, we can use different values of x here, or you can multiply all together and compare the coefficients. It depends on you. I will use using specific values, putting, and let this be equation second. Okay, putting x equals to minus 2 in equation second, we get 2 into 4 plus 3 into minus 2 plus 6 equals to a times 4 plus 3, and this part vanishes out, or 2 4 8, 2 times 4 8, 3 times minus 2 minus 6 plus 6 equals to 7a. That implies a equals to 8 by 7, right? Again, using x equals to 0, putting x equals 0 in equation second, we get x equals 0 means we are left with 6 only. 6 equals to 3a plus 2c, right? That is 2c, yeah. Or 6 equals to a is now 8 by 7. 3 into 8 by 7 equals to 2c, sorry, plus 2c. So 2c equals to 6 minus 3 into 8, 24 by 7, or 2c equals to 7 6 42 minus 24 by 7, or 2c equals to 18 by 7. That implies c equals to 9 by 7, right? Now to evaluate b, for easiness, let's use x equals to 1. Putting x equals to 1 in equation second, we get, so the RHS part will be 2 plus 3, 5, 5 plus 6, 11. 11 equals to, then here this will be 3 plus 1, 4, 4a, right? And then b plus c, and 1 plus 2 is 3, or 11 equals to 4a plus 3b plus 3c, or 3b equals to 11 minus 4a minus 3c. Let's use the values of a and c. A is We have a equals to 8 by 7, 8 by 7 minus c is 9 by 7 equals to 11 minus 32 by 7 minus 27 by 7. So we are left with 77 minus 59 divided by 7 is equals to 18 by 7. Therefore, b equals to 6 by 7, right? So we got all the values of a, b, and c. We can place them here, right? So 2x square uh, plus 3x plus 6 plus 3x plus 6 divided by, we have x plus 2 into x square plus 3, x plus 2 into x square plus 3 is equals to, we have a to be 8 by 7 divided by x plus 2 plus 6 by 7x plus c is 9 by 7 divided by x square plus 3 is equals to 8 by 7 times x plus 2 plus we have 6 and 9, we can take common 3, so that is 3 times 2x plus 3 divided by 7 times x square plus 3, right? And finally we can write the given question, this one, x cubed by x plus 2 into x square plus 3. Therefore x cubed by x plus 2 into x square plus 3 is 1 minus this term, right? And this term is equals to these partial fractions, 1 minus 8 by 7 times x plus 2 minus 3 times 2x plus 3 divided by 7 times x square plus 3. This is the final solution. Okay. So now let's look into the next problem in question number 6. Let's try to resolve x square plus 1 by x plus 2 whole square times x square minus 5 into partial fractions. Looking into this problem, we have proper rational functions. So let x square plus 1 by x plus 2 whole square times x square minus 5 equals to, now here is repeated linear factor, so corresponding partial fraction have the consist of the terms a1 by x plus 2 plus a2 by x plus 2 whole square, right, for the repeated linear factor. And there is non-repeated quadratic factor as well. For this we can write the partial fraction bx plus c by x square minus 5. Now taking LCM and rearranging, we have x square plus 1 equals to a1 into x plus 2 into x square minus 5. Then a2 have x square minus 5 only, and bx plus c will have x plus 2 whole square. Let this be equation first. Now before trying anything else, let's put um, let's put x equals to minus 2 in equation first. We get minus 2 square, 4 plus 1 5. Then with minus 2 this part vanishes out. right? Similarly, this section also vanishes out and we are left with a2 part only. So a2 4 minus 5, right? That implies a2 equals to, we have minus 5. So we got 1 at least value of a2. After that, let's try to multiply all these terms and try to equate the coefficients. Okay, equation first can be written as x square plus 1 equals to a1 into x plus 2 into x square minus 5. X plus 2 into x square, that will be x cube minus 5x plus 2x square minus 10. Then a2 is minus 5, so minus 5 into x square minus 5, right? And then we have bx plus c into x plus 2 whole square, that is x square plus 4x plus 4. Further, x square plus 1, this term comes to left side, so that will be plus 5x square minus 25, right, equals to a1 x cube minus 5x plus 2x square minus 10 plus, now multiplying this, we get bx cube plus 4bx square plus 4bx plus cx square plus 4cx plus 4c, or this will be 6x square minus 24 is equals to, let's separate x cube x square from the RHS part, a1 x cube and bx cube. So a1 plus b x cube. Similarly, x square parts. Here is x square, here is x square, here is x square, right? 3 terms altogether. So this will be plus 2a1 plus 4b plus c x square, right? Now let's go for the x terms only. 5x, 4bx and 4cx. So that will be plus 4b plus 4c minus 5a1x, and then terms involving variables only, constants only, like a1, b or c only, right? Here is minus 10 uh, minus 10 a1 plus 4c. Comparing coefficients, we can see a1 plus b equals to 0, right? Similarly, 2a1 plus 4b plus c equals to 6. Comparing coefficients of x, we get 4b plus 4c minus 5a1 equals to 0, and minus 10a1 plus 4c equals to minus 24. From here we can see a1 equals to minus b. So what we can do here is, let's use this equation. uh, let's replace b with a1. So b is minus a1, that's why minus 4a1 plus 4c minus 5a1 equals to 0, or 4c minus 9a1 equals to 0. If you can see these two equations, right, if you subtract them from each other, 4c minus 10a1 equals to minus 24, plus minus, uh, this will be a1 equals to 24, right? Therefore b is minus of a1, that is minus 24. Further, if you use another simpler equation, let's see, uh, this one. We have minus 10a1 plus 4c equals to minus 24, or a1 is 24 plus 4c equals to minus 24. If we take common, 4 common, then we'll have 4 times 6 is 24. So here minus 60 plus c equals to minus 6, or c equals to minus 6 plus 60 is 54. Therefore a1 is 24, a2 is minus 5, b is minus 24, and c is 54. Therefore x square plus 1 by x plus 2 whole square into x square minus 5 is equals to 24 by x plus 2 minus 5 by x plus 2 whole square plus minus 24x plus 54 by x square minus 5. That can be written as 24 by x plus 2 minus 5 by x plus 2 whole square, and here minus 24x minus 54 divided by x square minus 5. This is the answer. Let's see another problem, and this will also be our final problem. 4 plus 7x divided by 2 plus 3x into 1 plus x whole square. So this is a proper rational function. So let's begin the solution by supposition directly. Let 4 plus 7x by 2 plus 3x by 1 plus x whole square is equals to 2 plus 3x, linear non-repeated factor. So corresponding partial fraction of 2 plus 3x can be supposed as a by 2 plus 3x, and we have second term which is repeated algebraic linear factor. That's why corresponding partial fraction to 1 plus x square will be uh, let's say b1 by 1 plus x and b2 by 1 plus x whole square, right? Taking LCM and rewriting this, we get um, 1 plus x whole square plus b1 times 1 plus x into 2 plus 3x, and b2 will get 2 plus 3x only. So solving them, what we can do at first, let's suppose x equals to uh, putting x equals to -1, we get 4 plus -7 equals to, this part vanishes out, second term also vanish out, so we are left with b2 into 2 minus 3, right? Or 4 minus 7 is -3, 2 minus 3 is -1. That implies b2 is 3, right? We got value of b2. Now let's use another trick. Let's try to banish second term and third term by using x equals to -2 by 3. Putting x equals to -2 by 3 in equation first, we get 4 plus 7 into -2 by 3 and a into 1 plus x whole square. Remaining both terms will vanish because 3 into -2 by 3 means -2, 2 minus 2 is 0, right? Or 4 minus 14 by 3 a times 3 minus 2 1, 1 by 3 whole square is 1 by 9. Now 3 for 12 minus 14 by 3 equals to a by 9, or a equals to 12 minus 14 is -2 by 3 into 9. This will give you -6. And after this, let's put x equals 0 in equation first. We get 4 plus 7x is 4 equals to a times 1 plus x square. That will be a only, right? Then b1 into 1 plus x. 1 plus x 0, this is 2. So that will be 2b1 plus 2b2. We have known the value of a and b2. A is -6, 2b1, and b2 is 3. So 2 into 3 6, 6 6 cancel out, 2b1 equals to 4, implying b1 equals to 2. Therefore, our question 4 plus 7x, 4 plus 7x by 2 plus 3x 1 plus x whole square can be written as a by 2 plus 3x. So a is -6 by 2 plus 3x. We have b1. b1 is 2, so 2 by 1 plus x. And then we have b2. b2 is 3, so 3 by 1 plus x whole square. This is the solution. So we have solved various kinds of problems that are possible in examination from the topic simple partial fractions. I hope you understood the whole content. If you have any confusion, please comment below. Thank you.